create a NPM module that converts numbers from radix-64 to build radix-64 numbers. So basically it means when we write a decimal number that has base 10, so the way you convert from binary to decimal or from hexadecimal to decimal, similarly we are going to use the base 64. So which means if I write 0, that's going to be 0. If I write 9, that's going to be 9. If I write um, uh, 10, that's gonna be, say, A. If I write 11, that's gonna be B. If I write 36, similarly, that's going to be, or 35, it's going to be Z. Then when I write 36, that's going to be small a. And similarly, when we go on to write 63, that's going to be small z here. So basically we're going to use the sorry, not 63, it will be 61 and 62 and 63 we got to figure out, because if we add the total here is 0 to 9 equal to 10, a to z equal to 26, a to z equal to 26. That gives us a total of 62 numbers. We need to add 2 more characters, so we're going to use minus, hyphen, and underscore, because these two are URL safe. Basically these can be used as components inside a URL, although in base 64 encoding, which is the ISO standard, plus and slash are used, but we are going to use underscore and hyphen, for example, and these will get converted to 63 and the 64th letter here. So let's start with creating a new project. I'm going to use convert radix-64, and we will create this new JavaScript project on WebStorm. We'll start off with npm init, which gives a name for this node module. Convert radix-64 sounds good to me. Just go through everything else, and that creates a package.json for me. Let's go and create index.js file. Yeah, and here we're going to write the code for our radix-64 encoding, right? So we'll basically create something like this. And so given a particular integer to me, I will convert to 64 using this function. Given a particular string to me, I will convert using this function, and that's how this model will basically work. So we need a we need an alphabet. Okay, so we need a alphabet, and this alphabet should be something like 0 1 2 3 4 5 6 7 8 9, A B C D E F G H I J K L M N O P Q R S T U V W X Y Z. Same in small letters. Okay, so basically, why am I using this particular order? Let's so if we do something like this, sorry, let's say we take an array, um, a and 0, 1 2. Okay, so numbers come first, capital letters come second, and small letters come next, lowercase ones. So numbers, uppercase, lowercase, that's the lexicographical sort order that JavaScript follows. So we'll make it in that way. It will be easier, it will be more performant when we are using this particular alphabet. Okay, so we're getting is basically a string, and how do we convert a particular string, say if, an integer, say if I got the number 78 and I have to convert to base 64. How do we do it? We take 78, divide by 64, we get 1, and we get a remainder of 14. Okay, so that means the number would be let's say what's 14. 14 is mm, 14 is going to be E, and then number 1 is going to be 1, so my base 64 string is going to be this 1E. So we have to keep dividing a number by 64 and keep saving the values that we get, and finally the remainder that's left is the last digit, because a number in base 64, if it's written like 1111, which means 1 plus 1 into 64 plus 1 into 64 into 64 plus 1 into 64, 64, 64. So this is what the decimal is going to be like when I write the number 1111. So when we're going to do the reverse, we have to continue doing the same thing. We have to keep it dividing it by 64, and whatever comes out as the result, the final remainder is going to be the units character, and like that, so on. So if I get this particular function 264, what I'm going to do is first I need a function that uh, converts a number between 0 to 64 to a particular character. So for that, if I make a function like this, and this should return a new error if index greater than 63, okay, else return basic alphabet dot index of sorry, dot caret index. Okay, so this basically returns so if I send 3 here, it will return this. If I send 63 here, it will return this, like that. Oh, I forgot adding this. Right. So now I have to another function convert to 64 and give an int. What we do here is if give an int less than 64, return get 64-bit character of given int. Yeah, so we return 64-bit character of given int, else we are having we will continue to call this particular function. Basically we'll create a string. We'll call convert to 64 on the number given int. Modulo 64, which is the remainder that's left after we divide by 64. Okay, and Okay, so till now it works for numbers less than 64. I need to figure out what's the problem with the recursion out here. Yeah, so we've got numbers are getting generated. So here's how it's working. So when I'm calling 264, I'm making a call to the function convert to 64. The convert to 64 is a recursive function. If the given integer is less than 64, it returns um, basically get 64-bit character and of the given integer plus whatever previous value was there. And otherwise what it does is it calls itself again, convert to 64, it calls it again with the remainder of the division and with the string value of the quotient of the division. So every time we keep uh, calling it, it divides it by 64, passes the quotient, and then divides it again, passes that quotient again. So if the number is say with this, like the number is 63, or let's say you just increase the font size for the console. Here we go. Yeah. So if we have this thing, if I pass 0, it's coming out to be 0 up to 63. Works the same way. It hits this if condition, and so the recursive call is not called. But if I call 64, the number is less than, not less than 64, so it calls convert to 64 once again. And when it calls convert to 64 once again, uh, it does not go into this if condition. It goes here, and here it passes the remainder, which is 1 in this case, in back into this function, and the number 1. So I'm returning 1 plus whatever remainder is here. Similarly, if we go to a high number like this, it works. So now I've been able to convert 264. Now how do I convert from 64? So for the from 64-bit function, we'll do is we will go through we'll create an array digits equal to, okay, this will create a for loop of all digits. Then I will create a sum um, 0. Then I will run a for loop, and in the for loop what I'll do is sum plus base64 alphabet dot index of the particular string that I want, which is digits I. Okay. So this what we'll do is, if I have a string like this, say 17AB, is going to take 1, it will take 7, then it will take A and then B for each it will convert to decimal, add, convert to decimal, and like that. So it will be like 1 here, this will be 7 here, this will be 10, this will be 37, and the final result will be 1 plus 7 plus 10 plus 37. So let's see. Return convert from 64 to given string, and inside my text file let me add a couple of them. From 64 let me convert the number 1, then let me convert 1 1, let me convert AB. Okay, okay, that's coming out to be undefined. Convert from 64. Oh, I need to return the sum. Return sum. One is coming out to be 1. 11 has come out as -1. And why so? Let me just check if this for loop is running correctly. Okay. We remove all other logs that I had. Did oh, this needs to be an empty string here, and this will work. Cool. Let's do that again. And this has to be an integer of this value, right? Okay, so sorry, my mistake. I need to add the 64 as well here, which is sum equal to base 64 dot index of digits, multiplied by this, multiplied by math.pow, 64 and I. So yeah, because I need to basically add it like this, I need to add like 1 into 64 to the power of 3, 64 to the power of 2, and similarly okay, and I need to reverse this string so that I go from right to left like this and not like this. Am I right here? So 1 is 1, 11 is 65, and AB is 651, which is, let's check out if that's correct or not. 11 equal to 1 plus 64 into 1 into 1. If we write another one, 2BA 10570. So 2BA is equal to 2BA is equal to 2 into 64 to the power of 2 plus B into 64. B is basically 37th, and plus A is 10. Let's see how that holds out. That is actually 10570, and that's right. So I have been able to get a NPM module that converts an integer to a 64-bit character, a 64-bit alphabet, and back from a 64-bit alphabet here. So that's great. Let's see how we can publish this to the NPM website. So to do that, we should first take our package.json. We have a name, we have a version. Say I want to call this 0.1.0, a JS library that converts to and from radix-64 notation. As my main file, I have a script. So my test script should, let's just remove this for now. We will create some test and benchmark scripts later. See, license, I'd like to license this under GPL. and I want to release this. So let me first create a GitHub repository for this. Git init, git add a okay. Then I'm going to create a GitHub repository, hub create, convert radix-64. So awesome. And I'm going to git push origin master. Should I add a repository here? Then my repository would be so I've pushed my code to this repository here, so I should include that inside my package.json here. Okay, great. You can use the npm version command, which basically creates a tag for you at this particular version 1.0. Do that. If the version was already 0.1.0, if we want to create new version, you can do that. Say it was this in the beginning. Yeah. Uh-oh. Here we go. Right. So this is published to my GitHub. Now I want to publish it to Node NPM. So basically, you should go to npmjs.org, register for an account there, and you should log in or sign up. Okay, and once you've done that, you should do npm login, which will log you into npm. Now I am already logged into npm actually, because once you log in, you don't need to log in every time. It saves your credentials on your disk cache. Npm publish, and so this is where all the magic happens. So now I am banking on the fact that there are no npm modules with the name convert radix-64. I hope not. Okay, there isn't any convert radix-64 library, so I think me pushing this will work. I'm just going to publish that. error parsing JS. Okay, I think library is published. Okay, here we go. So convert radix-64 common JS library that converts numbers to and from JSON notation, and this is GPL 2.0 compliant. It has its source code should also get listed here. Let's go and add a readme also here. New so I'm creating a readme in a markdown format. With that, you can write other stuff, usage. I think there's no hyphen here, right? Right. Um, move this, and move this. Like that, and convert from radix-64 okay. Git add I think this is a bit of a mistake. 64 will not create this. 62 will create this. A will become 62. Oh shit, no. A is 10. A is 10. 64 is underscore. The alphabet used here is this. Let me just write that out in the README. Okay. So pushed that, and here we go. We have a README file here. Now, next time I publish to NPM, it will also show the README data here. Okay. Cool. So this is for part 1. In the next part, we will check out the following things. What are the things we'll do in part 2 is add tests, improve performance, which can be improved because, as you can see, we are doing a dynamic call to index of, and that can be improved if we convert this alphabet to a dictionary. Basically, if we convert this to something like this, A is 10 and like that. If I can convert B 11, stuff like that. Okay. So that way we can instead of caret we could use alphabet index. Okay. That is generally faster in JavaScript to do it this way. We will do that, and all of that stuff we will do in part 2. We will put up some we'll add some benchmarks, see how we can make this library faster, and we'll add some tests, and if possible in part 3 make this a native library, which would mean that I will have to write code in C++, use V8 bindings, and use Node JIP. Use Node JIP. Node JIP creates native libraries that can be used from Node.js. We will see how we can do all of that. Thank you for now.